this is acids, bases and salts review sheet. Again, use this as a revision starter if you've missed a lesson to catch up on certain things. Use it to help you with your revision. It's just an overview of the entire topic of acids, bases and salts. So to get us started, a little bit of a brief overview on what acids are and how they work. So the first question up here asks you to describe the pH scale. The pH scale is a measure of how acidic or alkaline a solution is. What pH does a strong acid have? Strong acids have a pH of about 1, sometimes even 0, up to about 3. Weak acids then, getting closer to neutral, have a pH of about 4 to 6. What does a strong alkali have? So on the other side of neutral then, which is 7. Strong alkalis have a pH of about 12 to 14. Weak alkalis then have a pH of about 8 to 10. The weaker they are, either be it acid or alkali, the closer they are to that neutral, that 7 mark. So what do acids contain? Acids contain a large solution of H plus ions. H plus ions mean that is what makes it acidic. Alkalines contain a solution of OH minus ions. What is the difference between dilute and concentrated acids? Dilute acids have a low amount of H plus ions in a certain volume. Concentrated means you have a high amount of H plus ions in a certain volume. It could be the same for alkalis. I've just used the question as acids. You need to remember this. This question comes up nearly every year. What do acids and alkalis contain? They might change alkalis for bases. So again, if you see the word base, do not be confused. That is just a type of alkali. Sometimes we use acids then to help us work out the reactivity series and how reactive an acid here. Here's just an overview of the reactivity series. It's more than likely going to be given to you, but as you can see, these have all been worked out and put in their place based on their reactions with acids. These ones at the top, these two especially, they react vigorously with water, let alone acids, going down to these ones. And then as you go further down the group, these ones don't react very well with acids, which is how you've put them in this order. How do metals react with dilute acids? The more reactive the metal, the more vigorous the reaction is. So the more reactive the metal is, the more vigorous the reaction is. Neutralization then is something that happens when you add an acid and a base, or I could change that to alkali, together. They form water and a salt. So that is what happens. What are the reactants? Acids and alkali. Don't know how I've missed off an I there. And then what are the products? You make salt and water. Unless you are adding a carbonate together, then you might make carbon dioxide as well as the water. You need to know then the names of certain acids and what the names of the salts they form are. So any hydrochloric acid will always form a salt ending in chloride. Sulfuric acid will always name a salt ending in sulfate, and nitric acid will always have a salt ending in nitrate. And then there's just some examples of naming salts which we have practiced in class. So lithium oxide plus sulfuric acid, that is going to make lithium sulfate plus water. It's always going to be plus water, plus water. Okay. The next one then is magnesium oxide plus nitric acid. Again, magnesium nitrate plus water. Lead oxide and hydrochloric acid would be lead chloride plus water. Unless this gets changed to a carbonate, then you'd be plus water and carbon dioxide. You are then asked to test for whether it contains sulfate ions or whether it contains carbonate ions. They both have different chemical tests. To test for sulfate ion, you add barium chloride and a white precipitate will form. So if you think something is a sulfate salt, add barium chloride to it and it will turn white. Describe the test for carbonate ions. So if you think something either started with a carbonate ion, because carbonate ions give off carbon dioxide, you just add the acid, CO2 is given off, and carbon dioxide always turns lime water cloudy. So that's how you test for carbonate ions. Now, 2 experiments you may have watched in class or had to go at yourself are the preparing soluble salts and titrations. So preparing soluble salts is in 3 stages. The first stage, I've just picked copper oxide and sulfuric acid as my elements. You add them together, add them together and you stir them. When you put them in a beaker and you stir them around, you should see a colour change and effervescence. That means that either hydrogen's been given off or carbon dioxide's given off, basically fizzing and bubbling. Stage 2, you filter the solution. So you've added them together. Likelihood is they're quite soluble with each other and they've dissolved. And then you filter the solution. You might be left with a bit of excess copper oxide left behind. That's why you filter it, so that what you're filtering through is just completely the mixture of copper oxide and sulfuric acid. And then stage 3, you put it in an evaporation basin and you leave it to evaporate. Can take up to 2 or 3 days, and that way copper sulfate crystals will form. It is not to say that it always be copper oxide and sulfuric acid. They're just the example that I used. The other thing you will have either done or be shown in class is to prepare a titration. Titrations, you use an acid and an alkali. You add the alkali to a flask, you add a few drops of an indicator, and then you add the acid to the burette, which is so you've got your chronicle flask here, and then the burette is a bit more of an accurate way of measuring something, and it's got the little tap by there, instead of just using a measuring cylinder or just pipetting it in. So in here you'll have your alkali and some indicator, and then here you'll have acid. And then what you do is you drop by drop the acid in and keep swirling it, moving it around until you see a colour change. So whatever colour indicator you added in here, so say you added a pink indicator in here, it would turn that pink, and then I'd wait for the acid to turn it back to colourless. So I'd be waiting for the chemical reaction to occur to colour change. As soon as the colour change occurs, that means that neutralisation of that alkali and that acid has occurred. Final bit then, you might be asked to do, this tends to only come up in the triple, but sometimes it's come up in the double. How would you use the results of your titration to work out concentrations of acid? You could use the volume that you had to add of the acid times by the concentration or the moles to work out whatever you need to work out. So you can use that equation.